Good morning, students. Now, in the last class, I have introduced the prism. What happens in a prism? Here, an equilateral prism which is there. This is an equilateral prism ABC. PQ is the incident ray, incident on a refracting surface, thereby refracts, bends towards the normal, and again another refraction is taking place through the another surface and coming out in this way. We have already shown this diagram. Now today the mathematical part. This angle is I, this angle is R1, this angle is R2, this angle is E. Okay, angle of incidence, angle of refraction for the first surface. For the second surface, this is the angle of incidence R2, E is the angle of emergence. Okay, emergent ray is RS and incident ray should go straight, but it has been bent, right? The overall bending by the angle delta. Delta is called the angle of deviation. Already we have seen. This is the figure. The angle of the prism is A. A is the angle of the prism. Actually, angle A is the angle of the prism, which is bounded by two refracting surfaces. So, what we can say? I can say here, if these two normals are drawn from N1 and N2 on these two refracting surfaces, and these normals are meeting at the point O. These normals are meeting at the point O. Then we can say in the quadrilateral, which one? AQOR. AQOR. Just mark it. AQOR. What we are getting? Angle AQO is equal to angle ARO is equal to 90 degree. And you know, sum of all the angles in a quadrilateral is 360 degree. AQO, ARO, each is 90. So, angle A plus Q, angle QOR should be 180 degree. I write this equation 1. Angle A plus QOR, remaining two angles, should be 180 degree. In the triangle QOR, let us take the triangle QOR. How much we shall get? In the triangle QOR, okay, R1 plus angle QOR plus R2 should be 180 degree. I take it equation 2. From equations 1 and 2 we get. From equations 1 and 2, what we get? We get QR will be here, right side will be equal, so QR cancel, so R1 plus R2 is equal to angle A. I write this equation number 3. See this. This is the equation number 3. R1 plus R2 is this value. Okay, now see, let us come to this triangle here, UQR. Now you take the triangle UQR. Delta is equal to exterior angle delta is equal to angle UQR plus angle URQ. Angle UQR plus angle URQ. So how much we shall get? This is equal to, see, this whole angle is I. So angle UQR should be I minus R1. I minus R1 plus, here it is I, and it is E minus R2. It is simple geometry. This whole angle will be equal to this vertically opposite. Here also this whole angle vertically opposite. So remaining will be this. So delta should be I plus E minus R1 plus R2. Delta is equal to I plus E, this value. Now putting equation, putting equation 3 in above equation. Delta is equal to I plus E minus angle A. So I plus E is equal to angle A plus delta. I write this equation number 4. Equation 3 and 4 are very useful equations, will be used in so many places, no problem. Okay, now I here apply a specific condition. Condition is this: if this ray of light is incident symmetrically on this side, that means on these refracting surfaces, that means if the ray PQ is incident symmetrically, then what will happen? Then I is equal to E and R1 is equal to R2 is equal to R से. देखो, अगर ये सिमेट्रिकली फॉल किया, इसका मतलब हुआ इधर का जितना भी एंगल्स है दूसरे साइड के एंगल्स उसका मिरर इमेज बन जाएगा एक तरह से, तो करस्पॉन्डिंग एंगल्स इक्वल होगा, यानी I के बराबर होगा, R1 R2 के बराबर होगा, and what will happen? And delta assumes its minimum value. Delta assumes its minimum value, that is delta is equal to delta M. What is this called? Angle of minimum deviation. इसे कहते हैं angle of minimum deviation. Then what will happen? Equation 3 becomes what? Twice R is equal to angle A, so R is equal to angle A by 2. And equation 4 becomes what? Twice I is equal to angle A plus delta M. Why? Because delta will assume delta M. So I should be how much? Angle A plus delta M by 2. Look, it is a special case in which we are getting these values for I and E. Okay, and after that we are getting these values. Then what we will have? I think I can remove this. All of you might have followed. You have seen. So I am removing. Here I write applying Snell's law. Refractive index for the material of the prism. Refractive index, according to Snell's law, the refractive index for the material of the prism is mu is equal to sin I by sin R. How much it will be? It will be equal to here sin angle A plus delta M by 2 by sin A angle A by 2. This is called Prism formula. Very important formula. It's called Prism formula. Look, this formula is called the Prism formula, and we are getting that angle like this, angle of minimum deviation. How to get the angle of minimum deviation? Now let us see how to obtain the angle of minimum deviation. Okay, on the graph. If I want to plot it on the graph, for plotting it on the graph, I am doing it here. See, I draw a graph for delta versus I. For taking different angle of incidence, if I plot the angle of deviation, then we shall get the graph like this. If I take the angle of incidence and different values of angle of deviation, followed, then we shall get the graph like this. And this is very important graph. this is giving us the value of delta m. Okay, this is the value of delta m. In this way the graph can be plotted. So delta versus I, graph of delta versus I in a prism. So this is all about the prism formula. Understood? And suppose here, since we have got the I just remove it here from here. I just take the case of, suppose I take the case of a thin prism. Let us take the case of the thin prism. Thin prism means what will happen? The prism is very thin, means angle of the prism, if ABC, thin prism mein angle of the prism will be very small. Sorry, angle of the prism, thin prism I am showing thin prism here. This is the thin prism, A, B, C. And what will happen? Obviously it will be like this. Actually in thin prism, IE angle A, right, R1, R2, all are very small. Mind this. A thin prism is that in which all these angles are very small, right? In that case, we can say from our main derivation, so I can get the values in the next lecture. I will give you, because the time is going to be up in this. So in that we shall apply Snell's law and we can modify the values, the expressions which we have obtained in a thin prism. Alright, so that we shall do.